All right, right now we are ready to start with the chapter 2 of this episode. The chapter 2 is talking about the electricity, about the flow of current, and what is the meaning of electricity and what is the meaning of current. Let me explain something. Electricity is exactly the same like the flow of any type of fluid, like the flow of water or any type of fluid. The electricity flow in the same way with similar properties. For that reason, we are going to use the comparison with the dynamic of fluids all the time in order to understand the dynamic of electricity with the flow of electricity. Yes, electricity is basically the flow of electrons. That's it. Simple definition. Electricity is the flow of electrons, and we are going to follow the law of one genius. Is the genius of the electrical system is Mr. Ohm. Really, in this course and in this program, we are going to follow the rules of three geniuses. The genius of the mechanical system, Mr. Newton. The genius of the hydraulic systems, Monsieur Pascal. And the genius of the electrical system, Mr. Ohm. And we are going to follow the formulas, the fundamentals of all of them. And let me check the formulas for all of those genius in relation with the force and those concepts. Okay, in mechanical systems, the name of the genius is Mr. Newton. And the formula of Mr. Newton states that the force is equal to the mass times the acceleration. In hydraulic systems, the genius is Monsieur Pascal. Monsieur Pascal states that the force is equal the pressure times the area. And in electrical systems, the genius is Mr. Ohm. I think that the genius is Mr. Tesla. This is other discussion. And Mr. Ohm states that the voltage is equal the intensity times the resistance. If you check, those three formulas are basically the same formula. We are going to try to understand later why it's the same. All of those formulas stay exactly the same with different fluid, with different elements. But right now we are going to concentrate with the Ohm law. The voltage is equal to the intensity times the resistance. This is the Ohm law. What is the unit for the voltage? Volts. What is the unit for intensity? Amps. What is the unit for resistance? Ohms. And those are the units that we are going to use from today until the rest of your life in electricity. Voltage is equal intensity times resistance. This is the Ohm law, and we are going to follow the Ohm law every day. We are going to follow that law. All right, the current. The current is the flow of charge, and is the rate at which electrical charge passes from one point to other point through a conductor. In order for a charge to flow, it needs a force. And it is supplied by a voltage or a potential difference. We are going to study later that when you read voltage, really you read the differential in potential between this point and this point. This is the voltage, the differential in potential. And the formula is voltage is equal intensity times resistance. Okay, the flow of charge. And we are going to start to study the batteries in the chapter 3. But basically, in a battery, the battery is a plastic container with a fluid, the electrolyte, and two metals inside. And the electrons start to move from one of the metals into the other metals, from the more noble to the less noble. And the electron flow from the positive, remember when the electron jumped out, produce a hole, and the hole is considered positive. From the positive terminals into the negative terminals is the flow of electrons. Yeah, this is very, very important. In a battery, the flow of electrons start from the negative terminal and finish into the positive terminals. However, the electricity occurs in opposite way. My friends, I apologize, I make a mistake. I want that you correct in your book this sentence because it's opposite. The electrons flow from the positive terminal and enter into the negative terminal. This is wrong. The electrons flow from the positive terminal, here is positive, and finish into the negative terminal, negative terminal. Sorry, I want that you make the correction. This is wrong on the book. However, the electricity flow in opposite direction. I am going to explain with a simple example what is the meaning of that. The electron flow in this direction and the electricity in the opposite, yes. This is like a complex concept, but it's simple. And right now I am going to explain that. Don't forget, the electrons jumped from the positive and enter into the negative. Alright? That's the most important part. Let me explain in a simple way the concept that the flow of electrons is in one direction and the flow of electricity in the opposite. You remember the genius of the mechanical systems? Yes, Mr. Newton. Mr. Newton formulated three formulas. The first three laws. The first law of Newton states that the force is equal to the mass times the acceleration. And the third law of Newton, because we are going to talk later about the second law, the third law of Newton is the law of oppositions. And what is the meaning of that? Mr. Newton said that when you apply a force on an object, the object reacts with an opposite force in the opposite direction. Yeah, this is the third law of Newton. And I think that the flow of electrons and the flow of electricity works exactly the same like the third law of Newton. When you apply one force in one direction, the reaction from the element is in the opposite direction. The flow of electron is in this direction, and the flow of electricity is the reaction in the opposite direction. Exactly like this, and this is simple to understand that concept. Until now nobody has been able to explain the phenomenon. Most of the books conclude that Benjamin Franklin made a mistake. No, Benjamin Franklin is right. In my opinion, in Lopez's opinion, the answer is in the third law of Newton. State that for every action there is an equal and opposite reaction. Finito. Alright? Okay, for that reason the electricity flows in different directions. Alright. In order to understand better that example, I put this example. When you sit in your chair, your body exerts a down force on the chair, and the chair exerts an upward force on your body. Simple. Other example is the wings of the bird push air downwards. Since a force results from mutual interaction, the air must also be pushing the bird up. The size of the force on the air equal to the size of the force on the bird. Correct. This is other good example. Alright, finito. No more examples. We are going to continue with electricity. Alright, I explained before what is the unit of the electricity? Amps. Amps per hour, because it's the flow. Amps per hour. The rate of flow of electricity charge is electrical current and is measured in amps per hour. Normally this is amps per hour. Alright, and the formula of Mr. Ohm states that the voltage is equal to the intensity times the resistance. The unit for the voltage is volts, for intensity is amps, for resistance is ohms, and this picture is a perfect picture to understand the phenomenon of the Ohm law. The Ohm law. This is the force. This is the flow, the amps, and this is the resistance. You see the face of this guy? The face of ohms, resistance. Alright, this is a perfect example for the Ohm law. Alright, let me continue with the Ohm law. According with the Ohm law, the voltage is equal to the intensity times the resistance. Let me explain something about this. For example, in the battery, you consider that the voltage of the battery is constant. Of course, the voltage of the battery decreases with the time, and at the end of the month, the battery is discharged. But in a short period of time, you can consider that the voltage of the battery is constant. What happens if you have constant voltage? What happens if you decrease like this? If you go down the intensity, this is constant. Of course, the resistance increase. In the opposite, what happens if you decrease the if you increase the intensity? Of course, the resistance goes down. Why? Because the voltage is constant. This is very important. If you produce more resistance, the intensity goes down. If you reduce the resistance, the intensity goes up. Let me explain something quickly. We are going to move the electricity, we are going to move the electrons in cables, in wires. How can I produce more resistance in the wire? How can I increase or decrease the resistance of the wire? Of course, if you increase or decrease the diameter of the wire. For that reason, this is the next couple of chapters, we need to calculate what is the gauge of the wire recommended for that motor, for that pump. The gauge of the wire basically depend of the amount of amps that you need to move it through the wire, and depend of the distance in between the load and the motor, and the battery, in between the battery and the load. We are going to calculate the gauge of the wires basically with two functions, with two considerations. One consideration is the intensity in amps per hour, and the second consideration is the distance in between the source of the power and the load. Alright? Okay, yes, if you increase the resistance, the flow decrease. If you decrease the resistance, the flow increase is opposite. Alright, my friends, this is the Ohm law, and you can organize the formula in different ways because voltage is equal intensity times resistance. You can say also that the intensity is equal to the voltage divided by the resistance, and you can say also that the resistance is equal to the voltage divided by the intensity. All of those three formulas are exactly the same. All right. And in order to use properly those formulas, I recommend the following picture. The following picture is excellent in order to understand what happened with the intensity, the resistance, the voltage, and the power. Because the Ohm law states two important formulas. Follow me. Voltage is equal intensity times resistance, and also power is equal voltage times intensity. What is the unit of the power? Watts. We are going to study later. This is volts, and this is amps. All right. Okay. In this circle, you found that all the formulas possible to calculate the voltage, to calculate the resistance, to calculate the intensity and power. For example, you can say that the voltage is equal to the intensity times the resistance. But also, if you have in this formula, you can say that the voltage is equal the power divided by the intensity. That one. And you can say in this formula that the intensity is equal the power divided by the voltage. Let me check intensity. Look, power divided by voltage. Yeah. And let me explain to you something. Suppose that I have this formula. Power is equal voltage times intensity. What happens if I replace this voltage for the formula of Ohm law? Power is equal to the voltage. What is the voltage? Voltage is equal intensity times resistance. And now times intensity. Okay, in other words, the power is equal intensity squared times resistance. Power is equal intensity squared times resistance. Yeah, if you replace this formula into this formula, or this formula into this formula, you founded all the formulas in this circle. Try to practice in your home in order to found the rest of the formulas according with the circle. This is a nice exercise, and if you do the exercise by yourself, it's excellent because you never forget in the future that situation. This is the formula for power, and the unit of the power is watts, and don't forget 1 kilowatt is equivalent to 1000 watts. 1 kilowatt is equivalent to 1000 watts. And don't forget that when you read voltage, you read the potential difference. When you read 12 volts in your battery, it's because one terminal have a 24 and the other one have 12, and the difference is 12. You read the difference between one point and the second point. When you read the voltage in the outlet in your home, is the difference in between the hot and the neutral. The difference is 120. All right? When you read voltage, you read potential differential. This is very important. And the next part is about the types of current. We are going to study two types of current. We are going to study DC current and AC current. The DC current is the current produced on the batteries. It's the current produced for electrochemical reaction. And the AC power, the power that you have in the outlets in your home, is a current produced for rotation of electromagnets. We are going to study later that phenomenon. Yes, DC current is a straight current, is produced for batteries, and this is a current that can be stored and can be transported. And the AC current is a current produced for rotation of electromagnet. That current immediately is produced, can be used. It's not possible storage, the AC current. This is a main difference, and we are going to study later those type of currents. We can convert DC current into AC by means of the inverter, and we can convert AC into DC by means of rectifiers, and we are going to study later both of them in details. And right now we are going to learn the procedure to use those concepts of electricity in order to create circuits and in order to do the wiring in a boat.